Okay, so the last section in this chapter is 5.8, inverse trigonometric functions integration. So you differentiated yesterday. Oh, did you guys have any questions? It was pretty straightforward, wasn't it? Okay. So our rules are as follows. Here. So if I personally would, I would change your du to a u prime myself. So I'll give you a second. Obviously, u and a have to be differentiable, and a has to be larger than 0. And so in that, you have the square root of a squared. So a would also obviously be the square root of a squared, right? So sometimes that's a nice number, and sometimes that is not a nice number. Okay, so we're going to try to make everything fit those. And today that will probably be everything. So the integral of dx divided by the square root of 4 minus x squared, I certainly would not write it like that if it was me. It throws things off. I would write it as the integral of 1 over the square root of 4 minus x squared, and put your dx off to the side. Because sometimes our brains trick us and forget that dx means just 1, right? So which one? Okay, so a would be what? 2, because it'd be the square root of that 4, right? And u would be, and so u prime would be 1. Okay, so all 3 of those rules had a, u, and u prime, yes? So which one of those rules does this one fit? Arc sine. Okay, so we know it is the arc sine. Arc sine just bugs me to write. Arc sine of u over a 2 plus c. So again, on this next one, instead of putting dx in the numerator, we want to just put a 1 and dx off to the side. To me, it just makes it so much easier. So the 3 things we need to identify on all of them are a, u, and u prime, right? So a would be the square root of 2. U would be 3x. And I'm going to, it's 3x because it's the square root of 9x squared, right? Yeah. Okay, so 3x. And so u prime would be 3. Okay, well, what form would that fit if it was going to fit any of them? Arctangent. Okay, so arctangent says I have to have u prime over a squared plus u squared, yes? So I don't have 3 in the numerator. No. I have 1, So what did I multiply by? 1/3. And then the rule is, I'm going to write it next, 1 over a arc tangent of u over a. So this 1/3 is not the 1 over a. Then the reason I wrote that is because I want to make sure that's clear that that's not it. Okay, so 1 over what? Square root of 2. Arc tangent of u, just 3x over a plus c. So let's clean it up a little. Well, this would be what? Square root of 2 over 6 arctangent of 3 square root of 2x over 2. I know it doesn't seem cleaned up, and I'm going to tell you the answer in the book is probably not going to be that, and it's not. They have 1 over 3 square root of 2, and then they have 3x over the square root of 2. It's gross. I don't want to deal with my brain thinking of anything about a radical in the denominator. How about you? Okay. Okay, I just have, they're just examples what I have, just different things. Okay, so the integral of dx over x square root of 4x squared minus 9. So what am I going to do with that dx? Make it not there. Just like now, I bet you never put anything to the square root of anything. You always put it to 1/2 or something, right? So we need to identify what things? A, U, and U prime. So A would be okay. Why did you jump to 3? Because it looks like arcsecant, right? It doesn't, where the other ones, the A was first and arcsecant at second, and the thing that's tipping you off there is this X in the front, right? Okay. You guys both did what you were supposed to do. Yay. Okay, so 3, and then so that would make U 2x, because we'd have the square root of the 4x squared. And then U prime would be 2. So we've got some issues here. The rule for arcsecant is U prime over U, the square root of U squared minus A squared. Yes? Okay, well, we don't have a 2 for U prime, do we? And we don't have a 2 for the 2x for U. So what happened to that 2 and that 2? They reduced, right? It wasn't anything extra added in. It actually just reduced out. So actually, I'm going to write it out just so we can see it. So we have 2 over 2x, the square root of 4x squared minus 9. So these 2's reduced out, and we do have what we need, right? Okay, so then my rule is 1 over a arcsecant of absolute value of U over A, right? Did I say that right? Yep. Okay, so that's going to be 1 over 3 arcsecant of the absolute value of 2x. Looks like a 12 over 3 plus C. So once you identify, and sometimes you're going to have to do some manipulation, sometimes you're not. So I have the integral of dx, so we're going to have the integral of 1 over the square root of e to the 2x minus 1. So what's that one look like? Arc sine. So try it. Okay, that doesn't work, does it? Okay, why doesn't this one work? Yeah, u prime would be 0, and that's obviously not 0, right? So arc sine is arc sine where the route we're going there.
That's why we should use arcsecant.
You think we should do arcsecant?
Because the E stuff.
Because of the E stuff.
Yeah.
Okay?
It'll just work out.
So because of the E stuff, if we used arcsecant, this would be my A, wouldn't it? I mean my U. So A would be 1, and U would be e to the x. And so U prime...
E to the 2. Or no.
No, it'd be e to the x, yes?
Okay.
Because it'd be the square root. But what is the derivative of e to the x?
E to the X.
E to the x. The trick, right? So let's fill it in like we did that last one so we can see what happens, okay? So if that works, if we are arc sine, we have du, which is e to the x, right? Over u, which is e to the x, the square root of u squared, so that'd be e to the 2x, minus a squared, which would be 1. So does that give me what I have over here? Yes. So sometimes you think it's one thing, but when you start working with it, you find out it's what? It's not, because it did not work. So then we are going to have 1 over a, so 1 over 1, arc secant of the absolute value of e to the x over 1 plus c. So that just leaves us with arc. Ew, that was going to be a horrible arc. I cannot stand to write arc. Anybody else?
I don't struggle with writing letters ARC.
I struggle with writing arc secant. I want to do the inverse secant because I just do.
The only time I struggle is writing arc cosine, because I'll just skip a C.
Because the 2 C's, yeah. I don't struggle with, my brain just doesn't want to write arc. Okay, now, do I have to have the absolute value on e to the x?
No.
No, because there's no exponent that can do that, right? So just e to the x plus c. Okay, so I got one more. Now you know I had to do this one, right? Because it was a little tricky. Think the next one might be a little tricky?
No.
No? Okay, so I have the integral. I should have asked, was everyone done with the other one? Integral of x plus 2 over the square root of 4 minus x squared. That right there, it's nothing, does it? No. But what have we done before when we have something like that? We've done what with our fraction? Have we pulled it apart? So we can pull it apart, so we can divide both. So I have the integral of x over the square root of 4 minus x squared dx plus 2, the integral of 2 over the square root of 4 minus x squared dx. Okay, which part do you want to do first?
First part.
First part? How do you want to do it?
Just have the
Do you want to do
practice.
like by substitution, right?
I suppose.
Don't you think? So if I wanted to do by substitution, I could rewrite it as the integral of x times 4 minus x squared to the negative 1/2. Yeah? Now, I did that because there isn't two. It's not going to fit any of those rules. It isn't going to fit the logarithm rules, right? Because that would be u prime over u. Yeah? So, can I integrate it just like I would normally integrate something?
Yeah, it's in order to do that. Probably not. I don't know.
Well, u would be what?
U 4 minus x squared.
4 minus x squared. So du,
2x.
say it again.
Negative 2x.
Okay, negative 2x. Okay. So, well, we're just missing the negative 2, right? So that would be negative 1/2. The integral of u to the negative 1/2 du. And again, I'm leaving the other one alone. Just working that way down. It's been a long time since we just did a basic power rule, hasn't it? Okay, so now we can integrate that, can't we? So add 1, multiply by the reciprocal. So if I add 1 to that, I get positive 1/2. So I get negative 1/2 times 2 u to the 1/2. So that would be negative 1/2. Actually, it would not be negative 1/2, would it? It'd be negative the square root
The square root
of u, which would be 4 minus x squared. So now I need to do the next part. So does that fit one of my rules I just learned today? So it has a minus, and there's nothing in front of the integral. So you would probably lean yourself to the sign, wouldn't you?
Yeah.
Okay, so if we leaned ourselves to the sign, a would be what? 2. U would be x, and u prime would be 1. Well, how do you make a 1 a 2? 2, which we could have brought that 2 out anyway, right? Okay, so we have 2 times, and we said arc sine works, right? So the arc sine of u, which is x, over a, which is 2, plus c. So that goes here and then keeps coming down. So this, I didn't put my equal sign. So then I have negative the square root of 4 minus x squared plus 2, the arc sine of x over 2 plus c. Now, people in the past have been tempted to reduce this 2 and this 2. Can I do that?
No, it's not. No.
Because it's in that arc sine, right? So can we mix different rules? Yes. And I'm sure that's my last example. We good?
Yeah.
Let me check, make sure. Yep. I have all these empty slides.